Hello class 11. This is Pankaj Kumar, your chemistry teacher. Today we will sum up the chapter number first, some basic concepts of chemistry. In this chapter we will discuss some topics: nature of matter, laws of chemical combinations, Dalton's atomic theory, atomic and molecular masses, and reactions in solution. Now, first of all, we will discuss the classification of matter. What do you mean by matter? Everything in this universe which have mass and occupies space is called matter. At the macroscopic or bulk level, matter can be classified as mixture and pure substance. Now, what is mixture? Mixture contains two or more substances present in it in any ratio which are called its component. Mixture can be classified into two categories: homogeneous mixture and heterogeneous mixture. What is homogeneous mixture? In homogeneous mixture, the components completely mixed with each other and its composition is uniformly throughout. For example, sugar, solution, air. Whereas in heterogeneous mixture, the composition is not uniform throughout and sometimes the different components can be observed. For example, mixture of salt and sugar. Now, what do we mean by pure substance? A pure substance is a material that has a constant composition and has consistent properties throughout the sample. In chemistry, a pure substance consists of only one type of atom, molecules, or compound. For example, copper, silver, and gold. Now, pure substance can be classified into two categories: elements and compounds. What do you mean by an element? An element consists of only one type of particles which may be atoms or molecules. For example, sodium, copper, silver, etc. What do you mean by compounds? When two or more atoms of different elements combines, the molecule of a compound is obtained. For example, water, ammonia, carbon dioxide. Now our next topic is significant figure. What is significant figures? Significant figures are meaningful digits which are known with certainty. There are certain rules for determining the number of significant figure. The first rule is all the non-zero digits are significant. For example, in 285 centimeter, there are three significant figures because all three digits are non-zeros. Second rule, zeros preceding to first non-zero digit are not significant. Such zeros indicates the position of decimal point. For example, in 0.03, there is only one significant figure, and in case of 0.0052, there are two significant figures. Third rule is 0 between two non-zero digits are significant. Example 2.005. In 2.005, there are four significant figures because these two zeros are lies between two non-zero digits. Now fourth rule is counting numbers of objects. For example, 2 balls or 20x have infinite significant figure as these are exact number and can be represented by writing infinite number of zeros after placing a decimal. That means you can write 2 equal to 2.00000 or 20 equal to 20.00000. That means in counting numbers of object, there are infinite significant figures. Now our next topic is law of chemical combinations. There are 5 types of laws. First law is law of conservation of mass. Second law is law of definite proportions. Third law is law of multiple proportions. Fourth law is Gay-Lussac's law, and fifth law is Avogadro law. Now first law is law of conservation of mass. This law states that matter can neither be created nor destroyed. It means in all physical and chemical changes, the total mass of reactant is equal to that of the product. For example, if we take the reaction of carbon and oxygen, the final product is carbon dioxide. Atomic mass of carbon is equal to 12 and atomic mass of oxygen is equal to 16. Then when we add 12 and 2 into 16, because there are 2 atoms of oxygen in this reaction, then we get 44, which is the atomic mass of carbon dioxide. This example proves that mass can neither be created nor be destroyed in a physical or chemical change. Now second law is law of definite proportions. This law states that a given compound always contains exactly the same proportions of elements by weight. For example, carbon dioxide can be obtained by any method. For example, when carbon and oxygen react, then it will give carbon dioxide. Decomposition of calcium carbonate is also gives calcium oxide and carbon dioxide, and decomposition of sodium bicarbonate is also gives carbon dioxide. In all methods, sample of carbon dioxide contains carbon and oxygen in ratio 12:32. That means 3:8. Now our next law is law of multiple proportions. This law states that if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of other element are in the ratio of small whole numbers. For example, when hydrogen combines with oxygen to form two compounds, water and hydrogen peroxide, then you can see that the ratio of hydrogen and oxygen in both reaction is 1:2. That means the masses of oxygen is 16 gram and 32 gram, which combines with a fixed mass of hydrogen 2 gram, possess a simple ratio, that means 16:32 or 1:2. Now our next law is Gay-Lussac's law. It states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. For example, when nitrogen react with hydrogen, so in this reaction, the volume of nitrogen is 1 and volume of hydrogen is 3. Then you can say that the ratio of volume of nitrogen and hydrogen is a simple ratio, which is 1:3. Now next law is Avogadro law. Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules. It means volume of gas is directly proportional to number of molecules. For example, if 100 ml of methane gas contain Y molecules and 100 ml of carbon dioxide gas contain Y molecules, then 50 ml of carbon dioxide gas contain Y by 2 molecules. Now next topic is Dalton's atomic theory. There are some postulates of this theory. The first one is matter consists of indivisible atoms. Second is all the atoms of given elements have identical properties including identical mass. It means atoms of different elements differ in mass. Third one is compounds are formed when atoms of different elements combine in a fixed ratio. And fourth is chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Now, our next topic is atomic mass. What do you mean by an atomic mass? One atomic mass unit is defined as a mass exactly equal to 1/12 the mass of one carbon 12 atom. Here carbon 12 atom is the isotopes of carbon. Next topic is molecular mass. Molecular mass is the sum of the atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by the numbers of its atoms and in them together. Molecular mass expressed in gram is called gram molecular mass. For example, if you want to calculate the molecular mass of methane, then what is the atomic mass of carbon? Atomic mass of carbon is equal to 12.0114 and atomic mass of hydrogen is equal to 1.008 U. Then we can calculate by following method: 1 into 12.001 U plus 4 into 1.008 U. Then we get 16.043 U. This is the molecular mass of methane. Now next topic is mole concept. The mole is the amount of substance of a system which contain as many elementary entities as there are atoms in 0.012 kilogram or 12 gram of carbon 12. Its symbol is mole. Mole is just a quantity. A mole of a substance or mole of particle defined as exactly the 6.02214,076 into 10 raised to power 23 particles, which may be atoms, molecules, ions or electrons. In short, for particles 1 mole is equal to 6.022 into 10 raised to power 23 and this number is also called the Avogadro number. And the molar mass of substance is the mass of 1 mole of that substance in multiples of the gram. This mass is called molar mass. Now, there is a picture in which you can calculate the mass, molar mass and number of moles and number of particles. This picture shows a relationship between the mass, number of moles and number of particles. If you want to calculate moles, then you must have divided the mass by molar mass. If you want to calculate the mass, then you have to multiply the molar mass into moles. If you want to calculate the number of particles from number of moles, then you must have to multiply by Avogadro number. If you want to calculate the number of moles from number of particles, then you must have to divide it by Avogadro number. Here mm means molar mass, which is also called the gram atomic mass or gram molecular mass, and Na equal to Avogadro number, which is equal to 6.023 into 10 raised to power 23. Now next topic is reactions in solutions. What do you mean by solution? Solution is a binary mixture in which there are two components, solute and solvent. Solute is always present in small quantity, whereas solvent is always present in excess quantity. In solution, we have to find the concentration. So there are four methods to determine the concentration. First one is mass percent, second is mole fraction, third is molarity, and fourth is molality. Now what is mass percent? It is the amount of solute in grams dissolved per 100 gram of solution. What is the formula to calculation of mass percent? Mass percent is equal to grams of solute, means mass of solute in gram divided by grams of solution, means mass of solution in gram into 100. By this formula, you can calculate the mass percent. Now next topic is mole fraction. Mole fraction of solute can be calculated by this formula. Mole fraction is denoted by X. The mole fraction of solute is equal to moles of solute upon total moles in solution is equal to small n upon small n plus capital N. Here small n represents the moles of solute and capital N represents the moles of solvent. Now mole fraction of solvent is equal to moles of solvent upon total moles in solution. The sum of mole fraction is always equal to 1. That means mole fraction of solute plus mole fraction of solvent is equal to 1. Now third is molarity. Molarity is defined as the number of moles of solute in 1 liter of this solution. It is denoted by capital M. The formula to calculate the molarity is equal to number of moles of solute divided by volume of solution in liter. The volume of solution must be present in liter. If volume is given in milliliter, then you must have to convert it into liter. Now fourth is the molality. What do you mean by molality? It is defined as the number of moles of solute present in 1 kilogram of solvent. Formula to calculate the molality is equal to number of moles of solute divided by mass of solvent in kilogram. You must have to calculate the mass of solvent in kilogram if mass of solvent is given in gram. Thank you.